biologist, and I specialize in coral reefs. Throughout my career, I've been extremely fortunate to explore some of the most beautiful coral reefs around the world. Unfortunately, the places that I've conducted my research have changed rather dramatically in a very short amount of time. And unfortunately, ocean ecosystems in general are overexploited, underprotected, and out of mind. So with the Hydrous, we are trying to translate scientific discovery into public understanding by digitizing and sharing threatened ocean ecosystems like coral reefs to contribute to marine science and make coral reefs and other ocean ecosystems more visible. So besides the general beauty and wonder of our oceans, why should we care about these ecosystems? Well, it turns out that oceans are crucial for the health of our planet and the survival of humans. We live on a blue planet. It covers most of our Earth. It provides more than half of the oxygen in our atmosphere. And if it were a country, it would be the 7th largest economy in the world. It also regulates our climate. And about 80% of all life on Earth is present only in the oceans. Coral reefs in particular support economies. They provide food and livelihood for hundreds of millions of people around the world. They protect shorelines from erosion, and they contain compounds that are used to treat human ailments. And coral reefs are also like the rainforests of the ocean. Even though they cover less than 1% of the seafloor, they harbor about 1/4 of all marine biodiversity. So unfortunately, ocean health is rapidly degrading. The vast majority of our fishing stocks are exploited. And in the last few decades, we've lost about half of our shallow water coral reefs. So the large-scale global stressors that are causing this crisis are mainly due to a surplus of carbon dioxide in our atmosphere, which is leading to rising ocean temperatures, ocean acidification, and sea level rise. The local and more direct human impacts, which are also more controllable, include unsustainable fishing practices, pollution like runoff and plastic pollution, and habitat destruction. So higher than normal ocean temperatures have caused mass bleaching of coral reefs around the world over the last few years. And reefs have been affected from Eastern Africa, across the Indian Ocean, Indonesia, up to Philippines and Japan, across the Pacific like Hawaii and Kiribati, the Caribbean, Florida, and an especially dramatic hit to the Great Barrier Reef in Australia, where I lived and worked for 7 years. So the study of coral reefs is really interesting in that it's an intersection between biology and geology, because corals are living animals, but they produce and build these massive geological structures. And in order to do this, they rely on a specialized type of algae, a symbiont that lives in their soft tissues and photosynthesizes, and that energy goes to the coral to build these reefs and create this important three-dimensional structure that supports these rainforests of the ocean. But when temperatures get too high, the coral animal gets stressed out and ejects the algal symbionts. And so without that, the animal turns clear. They're a soft-bodied animal that's related to jellyfish. Turns clear, and you can see through to its white calcium carbonate skeleton, hence why it's called bleaching. Now, a bleached reef is not a dead reef. It's more like a starving reef, but it leads to high rates of mortality. And here's an example. Footage from the same reef in Japan that I conducted research on last year and this year. And you see on the left, the corals are golden and vibrant because they have that algae that lives inside of them. Whereas on the right, the bleaching had already happened, and what we're looking at is dead coral skeletons. And it's not just about the corals. These reefs support incredible biodiversity from the smallest sea slug and shrimp up to sea stars and fish and whales and dolphins and sharks. And it's not just losing coral, it's losing these ecosystems. The good news is that we know what we need to do. In order to reverse the degradation of our underwater Earth, we need to curb global emissions, support sustainable fishing practices, reduce pollution, and strategically instate, expand, and enforce a worldwide network of marine protected areas. So the big question that I started to ask more and more as I progressed in my science career is, why is there this disconnect between the knowledge we have and our actions? We have so much clear evidence about the importance of our ocean, its ongoing destruction, and the solutions, yet the science does not easily translate into public understanding and action. And this is at least partially due to the fact that when it comes to climate science, human impacts, and the biological response, the general scientific output is just not powerful or accessible to most people. And even then, because people make decisions based on emotion and not rational thought, perhaps the goal should not be to convince with data, but to connect. By the way, all those images are from my publication, so I'm not picking on anybody. So with the Hydrous, our mission is to translate ocean science into public understanding, creating what we call open access oceans. And when we first got started, we became known for reality capture of coral reefs. So we use underwater photogrammetry, where we have a traditional DSLR in an underwater housing with strobes to collect multiple traditional photographs of a coral reef or an individual coral colony, then stitch it together into a digital model that can be edited and measured. And that measurement is key because with the software we use Autodesk Recap, we're able to chart growth over time and understand things like volume and surface area. And volume and surface area ratios are really important when it comes to understanding the health and complexity of coral reef ecosystems, as well as things like climate vulnerability. And of course, these models can be 3D printed, used in our education programs. And so I've already alluded to the fact that the three-dimensional structure of a coral reef is vital to the habitat health. However, traditional methods of measuring coral reef habitats are using two-dimensional methods like tape measures and rugosity chains to answer three-dimensional questions. And so, this is like trying to understand the expression on my face by measuring my silhouette of my face, and it doesn't tell you much. And so we've conducted underwater photogrammetry around the world. We collect models of individual coral colonies. Here you can see the gray rectangle show where the photographs were taken. And we're also collecting more and more models of large swaths of reef, especially now that the software allows for more and more photos. So this is an example of a reef in Hawaii that's about 100 square meters. And so this is a great way to document and monitor coral reef complexity, growth, and health using non-destructive in situ measurements. And so we take this 3D modeling a step further into engagement and education as well. So not only is our data available to researchers, but when we bring our 3D printed models into classrooms, into museums and art galleries, they're really wonderful in starting conversations about marine biology and climate change, and having something physical and tangible makes a huge difference. Believe me, I've spent years trying to talk to people about data, and it's not effective. And we've also been working to digitize and share museum collections, such as at the California Academy of Sciences. And so we're doing this for historical preservation, for research, and for education. Plus, digitizing these models makes them available to anybody who wants to view them. And I'm also pleased to say that we've begun working with the Smithsonian as well. We're working with the Digitization Program Office there and the National Museum of Natural History to help digitize and curate their coral reef specimen collection. And on my last visit there, we were playing with the idea of using augmented reality as a platform to bring more of these models into public spaces and into people's consideration. So back to the wild. The Hydrous has led expeditions all around the world, and our flagship location is in the Maldives in the Indian Ocean. And this country is on the front lines of climate change. About 80% of their land is less than a meter above sea level. And this country relies on fisheries and tourism to support their economy. On our last visit there, we noticed a lot of dead coral following the mass bleaching events and eroding coastlines. And two of our participants on board had the great idea to start monitoring using drones and created 3D models of islands. And this gray area around this island shows dead reef. So this method has great potential for long-term monitoring programs from a different perspective. And on our upcoming expeditions, we're continuing to scale up using more of this aerial photogrammetry to monitor islands combined with our larger coral reef swaths. Also on our expeditions, we collect immersive content. So here's a 360 photosphere collected at a manta ray cleaning station in the Maldives. And here's one of dead table corals in the Maldives, which interestingly has the most views on our online platforms. I think it has like 2 million views or something. So we're embracing immersive experiences in VR and 360 film as a new mode of storytelling and learning. And early research suggests that by donning a VR headset, you're more likely to retain information and generate empathy towards the issues. And I'd really encourage you to check out the VR experience at the Lenovo booth, which shows Hydrous models. It's this wonderful way to go diving without having to get wet or worrying about your ears clearing. And Horizon Productions did a phenomenal job, so please definitely check that out. And we're also creating a live-action 360-degree film that we'll be producing from footage in Palau that we hope to release next year, which, by the way, is the International Year of the Reef, which happens every 10 years or so. So I really hope that all of you will think about, learn about, and maybe even visit coral reefs in 2018. So to wrap up, I'd like to use one of my favorite quotes from a Senegalese forestry engineer named Baba Diem. In the end, we will conserve only what we love, we will love only what we understand, and we will understand only what we are taught. And to add to that, I would like to say that we can only learn about, understand, and love the things that we see and the things that we feel.